I'd like to do a couple of hours of streaming, see how it goes. So let's see. I think we're in good shape here. Let me just take a look at the chat. Take a look at the thing itself. It's working. Hello, hello, hello. I think we're in good shape here. Let me. Yeah, looks good. Okay. All right. Spend a little bit of time on this. I think we'll do a couple hours today and just get some practice in here. Okay. So, let's start with easy questions. Easy questions. So there's a few questions that are starting to kind of stack up a bit that this one is a new one. These I've looked at, but I didn't want to program because the solution I had was a little more complex. This one was a little bit complex. These two, there might be an easier solution actually for this one that I don't realize. And these two are also kind of complex, and I didn't want to, at the time, I didn't want to spend the time, but I can come back to it another time. So let's do some other ones, and maybe we'll come back to those other ones another time. All right. Move zeros in decimal representation. You're given a positive integer n, and return the integer obtained by removing all zeros in the decimal representation of n. Okay, this is fairly straightforward. Yeah, this is actually kind of easy, I think. Let's see. It's a long. Oh, it could be 10 to the 15th. Okay, it's interesting. Yeah, I mean, basically, I'm gonna try it this way. So let's try it this way. We're gonna say n greater than 0, n divide equals 10. Result is gonna be plus equals n mod 10. And then if n mod 10 is not equal to 0, then multiply by 10. I think it's the other way around, actually. It should be, we could do constable check equals 10 greater than 0, and say result times equals check times n mod 10 constant val. Not really sure if this is better or not. Something like this. Wrong. Okay. Output 1 should be 1, 2, 3. Multiply by 0. Oh, you know what? Yeah, this is wrong. It should be 10. And this is going to be multiplied by 1 or 10. Plus 1. So either multiply by 1, or this is multiply by 11, or multiply by 10. Something like this. Still wrong. This will reverse the numbers, though. So if I don't want to reverse the numbers, then yeah, this in reverse. I don't remember. trying to remember how this works. I want to say I mean, there are a few ways to do this. Yeah, this way is not really the correct way. The other way would be this is a slightly different way. Slightly different way. This is kind of one way of doing it. Not so sure about this. Basically having a position. Yeah, but that doesn't preserve, that would preserve the zeros then though. You don't move the position unless there's a non-zero value. That kind of works. I don't know if that's great though. This is kind of, it's a little awkward, you know. So I'm assuming there are no leading zeros. Which I'm not sure if that's going to matter. Invalid, yeah. There might be a better way to do this. I'm sure there is. Let me try this, see if this works. It took me a while. Okay, so I have the right answer, but let me throw this into the chat, into the machine and see what I get here. See if it gives me something a little bit better. I bet you there's a better answer than this. Critical bug. Tracing it. Oh, it's still going. Okay, it's actually this actually works. Okay. Oh my gosh. These things are so funny. Okay. The trick. It's a oops. It's a trick. It's a trick. Clever but obscure. Okay. Readability and negatives. Okay. Interesting. Where is you know what we could do? It's a little bit better than this. Where's the description? Well, a few things. few things. Okay, so ends one listed then and the 15th. And then do you think it's worth it? Use the if statement instead. Just thinking if branching here might be less efficient. Addition, how would you solve this? I'm curious. There's there's something there that's not obvious. What about the solutions other people had? Oh no, not that one. This one. Hmm. Oh, they just double reversed. I mean, you could do that too, I guess. Okay, that's actually a little bit easier, I think. That's probably easier. Generally preferred. It's valid in theory, negligible in practice. No, penalty is not predictable. Unreasonably. It's a random, effectively random. Predictors. Only a simple perceptron. Hardware level. Pretty sure it's just a perceptron. Branchless introduces a data dependency chain, can prevent the CPU from executing instructions in parallel. Extremely good at converting these into assembly. Readability outweighs the microscopic and non-existent performance gain benefit. 15 to 18 times. Oh, okay. Simple if statement. Correctness, readability. I think the negative one, they just flip it back. They just flip it to positive and flip it back. That's probably the easiest way to do that. Intermediate. No, I think long is only 10 to the 18th, so there's no risk for position overflowing. Conclusion does not hold. Technical why? Excuse me. Every single time, 15 to 20 cycles. Data dependency change. Latency is 3 to 4 cycles. Branchless version prevents the CPU's out-of-order execution engine from hiding latency by executing independent instructions like the next n equals 10 and divide equals 10 or loop overhead in parallel. If version breaks the dependency chain if the branch is predicted, or even if mispredicted, the recovery path is often faster than a long dependency chain. Generate a raw conditional loop for simple the conditional move, branchless at the hardware level. There's no branch misprediction penalty. Often has lower latency than integer multiplication instead of let's see what it does. Give me a moment. Let's find out. Give me 1 second. Let's see if we can find out. see if I could do this here. Hmm. Oh. 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 Okay. Interesting. Oh, that was good. Okay, just careful. Careful, careful, careful. Alright, we're gonna God bolt. Let's see what we get. Oops. Missed that. Okay. So I did this here, right? Okay. So let's see. GCC. I don't know. I'm assuming that's the right one. Inline or template functions manage generate code. No inline. This is inline. Hello? Attribute no inline. Huh. I'm not sure where that goes. I have to ask. How do I get this compiled to assembly in Godbolt? Okay, wrap it in a simple main. All right. Actually, I should probably just. Okay. Solution. Okay. All right, that's a little bit better. All right, there we go. And they said, O2 and O3. Gear icon, add the flags. Also, That is okay. I was gonna say it's a lot of buffering. Let's take okay. It's a lot of buffering. Not ideal, but not the worst. Let me also reduce the let's see the compiler optimization options here. 3. Dang. Okay. Okay, how about this? All right. Let's see what the compiler does. So I want to ask. Okay. Hmm. Oh. Hmm. Okay. Click on the line. All right. Let's do that. So this is main. Okay, I was gonna say it was like I think that's kind of it's a bit short. Okay, how about this one? Hmm. I don't know. Hmm. Delete the main function temporarily. All right, let's try this. I don't know. Okay, I don't need this. Compile. It's not compiling. It inlined it. Attribute no inline. Okay. I tried that before. Try it again. Compiler was like, this doesn't need to be oh, I think that might be the issue. Let's try that again. Uh, hidden. Compiler drop down for a button labeled filter. Ah, okay. Ooh. There's all this. Huh. I don't know about all this. Comments. I don't think any of this is what I'm looking for. It'll probably tell me that that's not. What is going on? No, I think it's just compiled it away. Volatile, use a dummy color. That's what I used before. Hmm. Um. Hmm. Perceptively filters. I don't think this is helps me that much. Okay. Let's put these back. Yeah, that's interesting. Does this need to be on another line, maybe? I don't think that matters. Nope. Cached. What is this? Hmm. Mm-mm. Only debug information. Okay. Hmm. Main, okay. That's what I had before. All right, so all right, let's do return. Sure. All right. Okay, there we go. Now we got something. All right. Okay. Successfully optimized your if statement to a branchless CMove instruction, validating the argument that manual branchless math is unnecessary. This was the code. Use this input. Let's see what it says. All right. Let's see what we got. Let's do a quick analysis here. So solution remove 0 is long, that is 0 is 0. Move RCX XOR test jump less than or equal, move XOR move abs. L3, move multiply SHR. Leah. It's less than or equal, rather. Jump less than or equal. Move, add, subtract, move. C move, not equal. So that's the conditional move, not equal. I multiply, add, compare. I forgot what this does. SBB, yes. and add I multiply, integer multiply, compare, move, jump. I think it's an unconditional jump. Okay. Conditional move. Oh, what's before I read that? Provided if statement is superior, even when the digits are random. Ignored your branchless math and generate a highly optimized sequence that effectively uses a conditional move strategy, but even with even more aggressive scheduling than a simple C move. This is a smoking gun. Despite writing, recognize the pattern emitted a conditional move not equal. It calculates val position only when val not equal to 0 by zeroing RAX if equal, then moving position to RAX if not equal. Crucially, this breaks the data dependency chain as the calculation of the next position can execute in parallel with the C move and E not equal, and the add R8 RAX because all the flags are set early. Position update logic. Your code compiler output sequence of CMP, CVV, and add I multiply. Compiler realized that multiplying by 10 or 1 is better done by calculating a multiplier 10 or 1 into RDX and then doing a single I multiply. Looking closely, this logic seems inverter specific to the flag state. Let's retrace. I have to sit and read the assembly code to see exactly what it's doing. I don't know all these instructions either, not offhand. Regardless of the specific bit total, the compiler is actually calculating multiplier equals val equals 0, 1, 10, efficiently using flags, and doing I multiply RDR, RDX, position multiply equals multiplier. Dependency chain comparison. Your code position depends on check, which depends on val result. The result depends on position. It's a strict serial chain. The C move not equal allows the CPU to speculatively prepare values. More importantly, the compiler schedule the position update such that it doesn't stall the loading of the next digit. Random digits doesn't hurt C move. True, random digits defeat jump. False, random digits do not affect C move. It has constant latency, usually 1 cycle on modern Intel AMD, regardless of whether the condition is true or false. It does not guess. It simply executes both paths internally and selects the result. Oh. Therefore, the randomness of your input is irrelevant. What is it? A conditional move. How is it structured? Silicon level. If I can be so bold. Further, more importantly, what does it do? How can it be a single cycle? Manual branchless attempts did not prevent the compiler from using CMove. Likely increased instruction counter dependency latency compared to the clean, forcing the compiler to work harder on tangler math. Obscured intent making the code harder to read without providing performance benefit. Use the clean version. The compiler generates optimal CMove based assembly that handles random inputs perfectly without branch misprediction penalties. Okay. All right. Let's do that. So if val is greater than 0, we're going to say result times equals position times val plus equals, and then position times equals 10. Get rid of this. Okay. Just double check this is correct. Let me just do it this way. We do want to inline this. Let's try it again. Okay. Okay. Let's see what we get. So what is this conditional move? Conditional move is a CPU instruction that copies data from a source register to a destination register only if a specific condition is met, if 0 if greater than. Unlike a standard branch jump, it does not change the flow of execution. The CPU simply executes the next instruction in sequence regardless of the outcome. Oh, interesting. High-level logic. Instead of this, branching probably generates this predication. Implemented as CMove. Silicon level structure, how it works. At the hardware level, CMove is an example of predication. It eliminates controlled dependency branches by converting it into a data dependency. The multiplexer model and MUX. Inside the CPU's execution unit ALU, a CMove instruction is effectively implemented as a 2-to-1 multiplexer. Input A, the current value of the destination register, the old value. Input B, the source register, new value. Select line. The status flag, 0 flag, carry flag generated by previous comparison. Compare silicon flow. Fetch and decode. The CPU fetches the CMove instruction. It sees 3 inputs, destination, source, and flags. Execution, the ALU routes both potential values to a hardware MUX. If the flag is true, the MUX selects the source. If the flag is false, the MUX selects the destination, effectively keeping the old value. Write back the selected result is written to the destination register. Visualize the logic gate. Source register, new value. Destination register, MUX. Destination register, old value. Condition flag 0, 1. Okay. So there's a source, there's the destination, there's a condition flag, and then there's the destination. Okay. No transistor path is cut off or redirected like in a branch. The circuit simply computes the selection logically. Oh. Why is it a single cycle? Claim that CMove is a single cycle instruction refers to its latency and throughput on modern microarchitectures like Intel Skylake plus AMD Risen, but requires nuance. No pipeline flush, branch jump. If mispredicted, the CPU must flush the entire pipeline and restart fetching from the correct address. The pipeline never stalls for prediction. The instruction flows through the standard execution stages, just like an add or move. Execution latency, typically 1 micro-op with 1 cycle latency, executes as fast as simple register move. Modern Intel CPUs, CMove is also typically 1 micro-op with 1 cycle latency. Okay. Interesting. Mispredicted branch costs 20 cycles. A correctly predicted branch costs 0 extra cycles, but adds a control dependency. CMove adds a data dependency, but guarantees 1 cycle execution time regardless of prediction accuracy. What does the data dependency do? CMove avoids the branch penalty. Forces the CPU to wait for the condition flags and the source value to be ready before it can compute. If the condition flags are produced by slow proceeding instruction, the CMove must wait stall for them. This is the data dependency cost. However, for random data, waiting 1 cycle for data is vastly superior to gambling on a branch predictor and potentially losing 20 cycles. Yeah, that's expected time is much better. Structure hardware multiplexer controlled by C. I actually don't know entirely what the hardware multiplexer. What is a whole hardware multiplexer? I actually don't know what that is. I should know what that is, but I don't. It's for some reason I'm like, I don't know what is that. Selects between keep old and take new without jumping. Okay. Avoids the massive penalty of pipeline flushes associated with branch mispredictions, making it ideal for unpredictable conditions. That's awesome. The assembly provided confirms that the compiler has successfully optimized the if statement to conditional moves. validating the manual branchless math is unnecessary and often counterproductive. Analysis of the generated assembly, usage, conditional move. Okay, got it. Effectively branchless regarding the zero check. CPU executes the same sequence of instructions regardless of whether the digit is zero or not, eliminating any branch misprediction penalty. Awesome. Magic number optimization, multiplicative inverse used to replace the expensive and equal to 10 operation. Oh, wow. So the compiler put a magic number optimization in there. That's awesome. Instead of using the slow div instruction, the compiler performs a multiplication by this magic number followed by a shift to calculate the quotient. This is a standard optimization for division by constants. Should I perform the magic number optimization or dividing by 10 myself in my code? Maybe I just assume compilers do this. Anyway, leave div 10 for readability. Dependency chain versus branching. Concern about random digits defeating the branch predictor is valid for actual branches, but because the compiler uses cmove not equal, there are no branches inside of the loop to mispredict. That's amazing. Clean with the if statement. Compiled into highly optimized branchless assembly using cmove not equal. Awesome. Do not use manual branchless tricks. Obscure intent and can prevent the compiler from generating optimal dependency chains. Trust the compiler to convert simple if statements into cmove instructions when appropriate. Awesome. We're going to come back to this in a moment. What does the data dependency do here? Data dependency. Good morning. What's up, Blan? How's it going? Howdy. Hope your day's going well. Howdy. Data dependency forces the CPU to execute instructions sequentially rather than in parallel, creating a latency bottleneck that limits how fast the loop can run. What it does, in yours remove zeros loop, a loop carried data dependency exists because the value of position result in the current iteration depends on their values from the previous iteration. The CPU cannot start the next iteration until the cmove not equal and I multiply for the current iteration have finished producing the new position. Silicon level impact prevents parallel execution. Modern CPUs are superscalar, meaning they can execute multiple instructions per clock cycle if those instructions are independent. Position iteration and +1 waits for position iteration, and the CPU cannot overlap these operations. Must wait for the latency of the dependency chain to complete before issuing new work. Even if the CPU has free execution units, they sit idle, waiting for the data to arrive. Latency first throughput. Predicted correctly, the dependency chain is broken. The CPU speculatively executes the next iteration before the current one finishes, hiding latency. Dependency is real and strict. The CPU must wait for the flag and the source operand. Modern CPUs, this adds 3 to 4 cycles of latency to the chain, since your loop only runs 15 times. This serial latency is negligible. In a loop running billions of times, this dependency would cap performance at roughly 1 iteration every 3 to 4 cycles, regardless of how wide the CPU is. Oof. Okay. Specific case, loop is too short for the dependency latency to matter significantly. Randomness of digits makes branch prediction unreliable. Trade-off, guaranteed 3 cycle dependency chains better than 15 to 20 cycle penalty. Data dependency forces the CPU to wait for each digit's processing to finish before starting the next, preventing parallelism. Serial cost is small and predictable. Okay. Given the data dependency, how might I approach this question? This question in such a way would not have data dependencies, since I only need to remove the zeros and the positions of the various digits. Somewhat implicit. Maybe there's a way to do this in parallel. Or at least it can be pipelined. The compiler. What do you think? We'll come back to the hardware multiplexer in a moment. Hardware multiplexer, often called MUX, a fundamental digital circuit, acts as a controlled switch, selecting one of several input signals and forwarding it to a single output line. Okay. What it does at its core, multiplexer routes data based on a control signal called the select line. Function, it takes 2 to the n input lines and uses n select lines to choose exactly one input to connect to the output. Okay, so it doesn't need that many select lines compared to the input lines. If the select line is 0, input A. Oh, I see. The n select lines tell you which input line to pick. That's why you could do 2 to the n. Oh, okay, I see. It just does basically does the select lines basically give you a binary number which line to pick. If the select line is 0, input A passes to the output. If the select line is 1, input B passes to the output. Roles in CPUs in the context of the CMove instruction we discussed, the MUX is the physical component that decides whether to keep the old value in a register or overwrite it with a new value based on the CPU status flags, like the 0 flag. Silicon level structure, transistor level. At the transistor level, multiplexer is built using logic gates and or not, or more efficiently using transmission gates. Logic gate approach, conceptual, simple 2-to-1 mux can be built from basic gates A, B, and select S. One AND gate takes A and not S. Another AND gate takes B into S. An OR gate combines the outputs of the 2 AND gates. Result, only the path enabled by S passes its signal to the output. So we have 2 AND gates and an OR gate. And that can give you a mux. Excuse me. Transmission gate approach, real silicon. Modern CPUs using CMOS technology rarely use the bulky AND OR gate structure for high-speed muxes. Instead, they use transmission gates. Structure a pair of complementary transistors, NMOS and PMOS. NMOS and PMOS is, I think it's it's not the doping. There's N-type and P-type doped silicon, but it's not NMOS and PMOS. NMOS and PMOS refers to basically the directionality of the transistor. It actually is. It is the doping, but it's NPN and PNP, I think. Although these are field effect transistors, so it's a little bit more complex than that. Yeah, it's something like that. That's what I think that's what it is for. I think BJTs by something or other junction transistors. I forget what the B stands for. That has the NPN and the PNP, but I think in MOSFETs it's actually a little more complex. There's I don't remember actually how it goes to the MOSFETs, but I think it's the directionality. And they use complementary transistors typically. So a pair of transistors connected in parallel, the select signal turns the NMOS on, while the inverted signal turns the PMOS on. Yeah, this is kind of like the transmission gate is similar to the inverter gate, but uses an extra signal line. Is that fair? I don't remember. I don't know. I don't know that much about silicon. I should know more, but I don't know that much. Not that I should know more, but I'd like to know more. I know a little bit, but I kind of struggle with some of these things. So when on, both transistors create a low resistance path, allowing the voltage to flow directly from input to output. When off, the path is broken. Okay, efficiency. This design is faster and uses fewer transistors, typically 6 transistors for a 2-to-1 mux, including the inverter, compared to the logic gate approach, which might be 12 plus. Visualizing the CMOS connection. When your CPU executes CMOS not equal, move if not equal. Select line. Just hold on a second here. Current value of Rax register AX, I guess. I'm not sure what Rax is. We'll value the value of, I guess, register A, X. Value of register B, new value, the 0 flag generated by the previous comparison. The mux inside the ALU, a tiny transmission gate multiplexer physically connects either input A or input B to the Rax register wire based instantly on that flag. However, a multiplexer is the transistor-based switch that allows the CPU to select data paths without jumping instructions, enabling branchless execution like CMOV in a single clock cycle. Okay. No, you should absolutely not perform the match number optimization yourself. Okay, trusting about it. Yeah, that's kind of what I thought. I was like, I don't know if that's a good idea. 0 performance advantage. Okay, got it. Data dependency. Hold on a second. Sorry about that. All right. Okay. So. All right. How are we doing? I think it's been almost an hour here. All right. So what am I doing? Huh. See another here. What am I doing? Okay. Huh. See. Let me do something here. I think I'm trying to decide what I want to do exactly. Okay, let's finish this topic. So, basic idea is that I should keep it simple as far as this is concerned. Breaking the loop carry data dependency for single 64-bit integer is theoretically impossible because the position of each digit fundamentally depends on how many non-zero digits preceded it. You cannot know the final position of the digit 5 until you've counted the non-digits before it. You can approach this differently depending on your goal. Parallel approach, process digits as a string. If you convert the integer to a string, or process its bytes directly. Use SIMD single instruction, multiple data instructions to process 16 or 32 digits simultaneously. How it works: load 16 bytes digits into a vector register, compare all 16 bytes against 0 in parallel, generating a bit mask. Use a shuffle or compress instruction. It doesn't have that many bytes though. Store the result. This removes the dependency between digit n and digit n plus 1 within the vector. You process chunks independently. Still have a dependency between chunks. It's usually solved by a 2-pass algorithm or parallel prefix scan on the bit mask of non-zeros, which is complex to implement for a single 64-bit number and likely slower due to overhead. Pipeline approach cannot remove the dependency, but you can hide the latency by processing multiple numbers at once. Your problem allows it. You need to remove the zeros from a million integers, not process them one by one until you leave the processing of 4 to 8 digits in the same loop. Okay. Oh, interesting. Okay. Mathematical reality for a single number. For a single number, can unroll the loop manually. Since it's max 19 iterations, this allows the compiler to schedule independent instructions like the division by 10. the next digit earlier, overlapping them with the multiplication of the current digit. Branchless table lookup instead of, you could pre-calculate powers of 10 and use a counter. Branchless table lookup. This replaces the dependency chain with a simple addition and a memory load. Additions have lower latency than multiplications, slightly shortening the critical path. Huh. Okay. For a single number, the dependency is unavoidable because the problem is inherently serial. So prefix output position of a digit is a prefix sum of previous non-zeros. That's true. Best single number solutions stick to the clean if version. The compiler C-move magic number division is already optimal for a serial chain of 15 items. Manual unrolling or SIMD adds code size and complexity for negligible gain on such a small data set. Best multi-number solution if processing arrays of numbers, use interleaving or SIMD to break the dependency across different data elements. Okay, so it's kind of unnecessary to like overly optimize this, I guess. All right, how are we doing here? So I think okay, let me try this again. Right, that kind of covers the it's partially fair, but misses a key structural difference. The inverter is actually an internal component required to make the transmission gate work with a single control signal. Here's the precise breakdown. Extra line signal line nuance. Inverter has one input and one output. It actively drives the output to VDD or GND. Transmission gate has two data terminals, input output, since it's bidirectional, and one control input. Okay. However, internally it requires two complementary control signals, one for NMOS, one for the PMOS. If you only have one control signal, which is typical, you must include an inverter inside the transmission gate circuit to generate the second inverted control signal. Rather than saying it uses an extra signal line, it's more accurate to say a transmission gate is essentially a pair of switches controlled by an inverter. Okay, so structural comparison, transistor level. CMOS inverter has two transistors, the NMOS and the PMOS. CMOS transmission gate has two transistors, NMOS, PMOS, plus two for the inverter, so 4 total. Okay. Single control input. The connection for a CMOS inverter is going to be in series, PMOS on top, NMOS on bottom. And then there's going to be the I think it's VDD and GND connected. Then CMOS parallel, NMOS and PMOS sources, drains connected together. Okay. Connected to VDD and GND for the power pins of the CMOS inverter. No direct power pins. It's a switch, not a driver. Okay, interesting. And the function logic output's not input. Switch passes input to output or blocks it. Okay. Input directly drives both gates. Input drives NMOS. Inverted input drives PMOS. Okay, interesting. Inverter is critical. The NMOS, I don't fully understand. I have to think about this a little bit more about like why this works, how this works. The NMOS transistor passes a strong 0 but a weak 1. The PMOS passes a strong 1 but a weak 0. Pass a full strength signal both 0 and 1 without voltage degradation. You need to both transistors on simultaneously. Since NMOS turns on with a high signal and PMOS turns on with a low signal, you cannot drive both gates with the same wire. Solution: you feed your control signal into an inverter. The original signal turns on the NMOS, and the inverter's output, the opposite signal, turns on the PMOS. Oh, interesting. Intuition is close. The transmission gate contains an inverter to manage its control lines. Fair statement. Transmission gate is like a bidirectional switch that requires an inverter to generate complementary control signals for its parallel transistors. Unfair statement. Just an inverter with an extra line. Fundamentally, a switch structure, whereas an inverter is... Oh, okay, got it. I understand what they're getting now. All right. Okay, fair enough. Let me see something here. Let's do another question, I suppose. I think Let me spend a few more minutes here. All right, so that was interesting. Did some learning with the compiler explorer. Let's try another question. All right. Display table of food orders in a restaurant. Given the array orders, which represents the orders that customers have done in a restaurant, more specifically, orders of I equals customer name sub I, table of numbers sub I, food item sub I, where customer name sub I is the name of the customer, and table number sub I is the table customer sits at. Is the table customer sit at, and food item sub I is the item the customer orders. The name of the customer, the table the customer sits at, or will sit at. Okay, return the restaurant's display table. The display table is a table whose row entries denote how many of each food item each table ordered. The first column is the table number, and the remaining columns correspond to each food item in alphabetical order. The first row should be a header whose first column is table, followed by the names of the food items. Note that the customer names are not part of the table. Additionally, the rows should be sorted numerically, increasing order. Okay. So you've got a bunch of different orders rather, and you've got different outputs. Explanation, the displaying table looks like table beef burrito, ceviche, fried chicken water. Table 3, David orders ceviche and fried chicken, and Roos orders ceviche. Table 5, table 10. Okay. Orders 50,000, order length, customer name, food item length. Okay. All right. It's numbers between 1 and 500. Okay. Let me, oops. Give me a moment here. I think I need to have this. Give me a moment or two. Let's see. So we'll solve this one and stop, I think. We'll take a break. So there's a table they want. Displaying table looks like this. Table, beef burrito, ceviche, fried chicken, water, which says table 3, 5, 10. And then I think how many there are at that table. Excuse me. So here are the orders. The people in the tables. It says 1 ceviche, 2 ceviche, 3 ceviches. And so we'll have the table number, and then we'll have how many ceviches at that table, which is 1, 2, 3. So there's 2 at 3 and 1 at 5. Okay, I think I understand. It's kind of like a hash map type of thing. All right. This isn't too hard, I think. 50,000, and then they want us to just print that out. So, okay. I mean, I suppose this is fine. For each order, we're going to say const auto string or vector orders. These are various strings. Going to have a result that we return. I don't know how large that result's going to be. And it's going to be the number of tables. So we should have a table. Be 500. We're going to use a static. Yeah, we're going to say static. How many different? There could be a few. Actually, I don't know if this should be static. We don't really care about the customer names. We really care about the food items and their counts. There could be a lot of food items. So Okay. So in that case, we'll say basically each food item should get its own array. Yeah, each food item will give me, okay, let's do that. Food item frequency by table. And this is going to be integers. Does it matter what the order is? Should be sorted in numerically increasing order. Okay. The rows should be sorted. All right. How many each table ordered? First column is the table number, remaining columns correspond each in alphabetical order. Okay, so the food items are going to be alphabetical. I mean, could do string. Yeah, I mean, yeah. It's one way of doing it. I mean, this isn't too bad. Frequency by table. And then we would just sort these by, how do you sort them? The rows should be sorted numerically increasing order. Okay. Yeah. All right, that's fine, I guess. Okay. Yeah, we'll build the result afterwards, I think. This is kind of a peculiar thing, but all right. So let's do const auto s1 is v0, s2 is v1, and s3 is v2. Wondering if s1, s2, s3. S1 is just thrown out completely, I think. We don't even care about S1. We just want the table and we just want S2 and S3. And we're going to say food item frequency by table. What we're going to do is, so if I mean, this also is supposed to be a map, isn't it? It's kind of supposed to be a map. Yeah, I mean, could just do an array, keep it simple. Something like this. I don't know the syntax. I don't know if 500 comes first or comes second. We don't really need to do it that way, do we? Um, value initialized. Okay. Flip it that way. Yeah, it comes second. Okay. I like this. We'll do it this way. All right. And then we'll just say, string. Table is S2. What's better for? There might be something better than std s2i. And this is going to be basically increment s3. And then the result is going to be something like the following. For int I is 0, I is less than 500. Increment I, so if food item frequency table is not empty, then so first thing we do, I think 502. Hold on. String, I don't know. Let's just do it this way. First line. If not, get first line, or have first line. Bound first line. So what we're gonna do is say we haven't found the first line. Then we're gonna say we found it, and then we're gonna dump everything into the result for the first line. So we're gonna say for yeah, we're gonna have table and then okay, so for auto pointer equals, let's do const auto reference, just map, or is going to be food item frequency by table of I. Probably should make that actually the first one. So if M is not empty, then we're going to say if we haven't found the first line, we're going to say take a pointer to m.begin, and pointer's not equal to m.end. and increment a pointer. And we're going to say what is this? This is a vector of strings. Okay. Stood vector stood strings of first line. And then we're just going to say push back. Yeah, okay, that's fine. Say first line push back table. First line push back. It's going to be pointer first. Okay. Yeah, basically. And then we're going to result that pushback move. First line. Okay. Also going to have int unique items. And we're going to say unique items equals first line dot size minus 1. Okay. Now, if we have found the first line, otherwise, actually, no, even so, then we're going to do another loop, which basically just creates a stood vector string next line. It's line dot reserve unique items +1, and let's say just line size. We'll say it's probably better. Line size, and then we'll say line size here. And then we're going to say for each of these, next line, just going to push back the second value. First push back the table name, which is I. Okay. And these are string to I, or toString. This ended up being a lot more complicated than I thought it was going to be. By the way, this is probably a lot easier with Python. Or not, it's not that it's easier with Python, but I'm sure Python, you could do it in a way that's a lot more cleaner, I guess. So, yeah, I mean, and then we say results dot push back. That's the move. Excuse me, next line. Okay. Something like this, I think, is correct. It's pretty involved overall, but I think it works. Okay, let's see. Got something wrong here. All right, my output 321, 511. I'm missing one of these, and they're expecting more. 1, 2, 3, 4. Huh, what happened to the beef burrito, the fried chicken, and the water? Or what happened to the beef burrito and the water? I did get 3, 5, 10, but I'm missing, should be 4 of these coming. Yeah, I'm missing 2 things here. What happened there? Definitely had water. Okay. Right. What? Well, what happened there? Hmm. Let me print this. Let's go ahead and do a couple things here. Huh. And oops. And the other one. Hmm. I don't know, man. I mean, I kind of know what I'm going to see, but I don't know why I see that. I'm sure there's something silly that I did here that I didn't realize. Okay, so we got the water and the beef burrito do show up, but I don't see the water in the beef burrito. Oh, that's subtle. I got it. Okay. Tisk, 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 tisk. Okay. Can't do it this way. And I can't quite do it this way. I mean, I can still use the map. It's a little awkward. I could do better than that. Yeah, let's not use the map. Okay, let's do something a little more sophisticated. Something a little bit more sophisticated. Actually, the map might be better. Now I'm thinking about it. I'm trying to decide. If we use the map, it's fine. All right. Order type. Use a set. Instead set. This still kind of works. It's just a little less. Yeah. This isn't so good. I think this could work. There's a few ways to do this. Yeah, that's a bit awkward. Sure. We don't need a line size anymore. We don't need to find the first line anymore. That's necessary. All right, we're gonna do it a little bit differently. Gonna do it like this. So it's order type insert, and we're gonna say for each order type. So, oh wait, I should actually hold on to this. Let's go back. There we go. Okay. We don't need this part. I am going to create this first line though. And gonna reserve order type size +1. Okay. Push back table. Very good. This part is really going to be order type begin. Okay. And this is really just dereference this one. We don't need the line size anymore. And then after the oops, it's for loop. You can go ahead and After this for loop, we can go ahead and push. Go ahead and push this back. I'm wondering about. I'm wondering. I want to say. Order index. Um. Maybe it's the way to do it. I don't know, man. It's a little weird. It's a little weird. All right. There's a lot of like things going on here with order that makes it awkward to do it in one pass. I was thinking about just doing 2 passes, but I don't think it's necessary to do 2 passes. I think it's fine to do 1 pass. First. Yeah, there we go. That's the one. All right. Okay. Food item frequency by table. Food item frequency by table. So the deal with this is okay. Next line size doesn't do line size. It's going to be order index.size. This one. Push back the number, and now we're going to do hemmed up again. So it's actually not even reserved. It's actually going to be explicitly index size. Empty string. I don't know if I want to do it like that exactly. Huh. Yeah, actually, that's fine. Yeah, that's fine. That's a little bit wonky. Okay. Okay. And then now we're gonna say these should be zeros actually. That's even better. Let's do it that way. I like that. That's a good way to do it. Let's do it that way. So now we can say next line of is equal to where second order index of winner first. That's what I want. Beautiful. That's a lot better. That's a lot easier. Okay. Okay, I think that makes a lot more sense. Let's try that. It ended up being really involved. Wrong answers. Okay. But all right, we got 3, 5, and 10, which is what I wanted. But then now I have U1, U2, which is not what I wanted. It should be 0, 2, 1, 0. Oh, it's close. Not quite right, but it's closer. These shouldn't be unsigned. I don't know what's going on there. Huh. Interesting. What? Huh. What? What is going on, man? Did I at least get all the categories? I did. Beef burritos, ceviche, fried chicken water. I got all that. That's good. Then this 3, 0. Yeah, I don't know what's going on there. Okay. Order index, next line equals order second. This should be 0. Overwritten. Push back the next line. Should be fairly straightforward there. These are integers, yeah. Food item frequency. The table is integer. Oh, that's interesting. Order index pointer first. Yeah, let's get to the index next line. Which position in the next line? That'll be second. Yeah, that should be right. I don't know. What's going on. What in the world's going on here, ma'am? What in the world's going on here, ma'am? Okay. So I got ceviche 2, fried chicken 1. Okay. So that should be a 2. Fried chicken should be a 1. Which, this isn't quite right. For some reason, oh, I think I know what's wrong. Well, I think I know it's one thing that's wrong. There's one issue here for sure. This needs to be a +1. That's a slight error on my part. No. Okay. Okay. Let's do +1 here. That might be more what I want. This maybe needs a +2 then. Yeah, I don't. That's a lot. Okay. All right. Still wrong, but oh, this is so awkward. Should be 1, 2, 3, 4, 5. It's not quite right. No. No. Okay. The order index +1 is fine. Size +1 is fine. The indices themselves are going to be shifted by 1. So that should be okay. this should just be as it is. So why doesn't this gives me a runtime error for some reason? Yeah. Okay, it's overflowing, but that's not a. Should get index 2, which means 0, 1, 2. Why does that give me a problem? First one should give me a 0. Zero, 1, 2, 3, 4. 1, 2, 3, 4. This is wrong. This is just wrong. Something's wrong. Something is wrong. What is going on? It's a bunch of things here that aren't making sense to me. I'm missing something important, something subtle. Not the best choice from chars. It's better. Okay. From char struct pointer and error code. Okay. From chars is probably what I want. Okay. We'll come back to that. From chars, that's probably what I should be using. Zero, 1, 2, 3, 4. Oh. I see what I did wrong. Okay, got it. Right, there's a from chars routine. Let's see that. Give me 1 second here. I see what I did wrong. Got it. Got it. Oh no. I don't use this very much. I have to kind of read it a little bit. Whoa. Bet that hurts your eyes, huh? All right, we'll come back to the from chars thing. I see what I'm doing wrong. So this is kind of subtle. It's if order index dot find of S3 is auto pointer if this pointer is not equal to order index dot end, or rather if it is equal to that end, then we're gonna do this. That's interesting. Okay, got it. Yeah. Yeah, and we can just. I think I managed to confuse myself a little bit there. Okay, let's try this. There we go. 0, 1, 2, 3. Okay, that's why it was so confusing. Okay. Now it should be shifted over by 1. All right, got it. Just gotta say, I was like, wait a minute, something's not right here. Okay. Now this should be able to make a little more sense. Okay. Okay. So this should be 0, 2, 1, 0. Okay, it's still wrong, but it's a little bit better, at least. Oh, this is also wrong. Shoot. Yeah, this is incorrect as well. Okay, this is wrong. This is wrong too. Yeah, I did this wrong. Okay. All right. Okay. I think this is part of the issue. Oh man. Gosh. Yeah. That's awkward. Still wrong numbers? I think I understand what's going on here. Oh. Understand a little bit better. This should be start off with 1, actually. Okay, a little bit better. There we go. 2, 1, 0, 1, 0, 1, 1, 0, 0, 0. Okay, getting a little bit better, but these shouldn't be U0. I don't know what's going on there. There's like characters for some reason. For some reason, these are being interpreted as characters. I don't really know why. I'll add the from chars thing back there soon. I don't know what's going on here. I don't know. This should just be an integer. I don't know why it's not an integer. Oh, maybe because they need to be converted. Oh, that's why. I got it. It's 2 string. That's all. I was wondering. I was like, what is going on here? I forgot about that. That's why. Okay. Got it. That's why. All these subtle things, man. Subtleties. From chars. First, last. Character sequence. Okay. Stood from char's result. Auto pointer error code. Stood error C. Result. Quoted. Oh, I like that. I should use that more often. Quoted. Just pointer. What does it return? String view? I don't know. I'm not sure what that's gonna be. All right. Let's do auto pointer error code. Stood from chars. This to begin. This to end. And then just say where. What? I don't know. Hold on. What? String data plus string size result. Oh. Int result. Okay. All right. How about this? I'm not sure what oh boy. Okay, there we go. That works. I think I just go for it now. Afraid to go for it, but I think this works. Okay, it works. Beats most solutions. That took forever. That took so long. That took me so long, man. Jeez. Hey, what's up, yes, I hope. See the chat, man. How you doing? Howdy, howdy. Howdy, howdy, howdy. Okay, well, it's faster than most solutions. That's pretty good. But, dang. Dang. Not sure what to say. Let's see what the chatbot thinks. Let's see what this guy thinks here. Dang, man. I mean, okay. We got there. I'm good. What about you? I'm okay, man. I'm all right. Hanging out, doing some problem solving. Although I kind of wanted to do this a little bit quicker. This took me a really long time. 2 critical logical errors. Okay. Huh. It kind of gets stuck. There's actually an optimization I could throw in here. Let's do it this way. We're going to do static. And then we're going to say for, oh, no. Afterwards, we're going to say m.clear. Okay, let's try this. I think this is still correct. Ooh. Oh, not constant anymore. Yeah, this is an interesting question. Maybe I should show what the question is. Let's see if this is correct. A little faster. Not the fastest. Let me show the correct question. This is kind of an involved question. This took me a while, man. This took me a while. This is kind of a lot trickier than it seems. A lot trickier than it seems. You doing it for the practice, or is it like assignment type work? Practice. It's practice. Yeah, it's practice. Yes, sir. Yes, sir. Found a subtle bug. Is it correct? Logically correct. Specific logic check. Performance issue. Specific bug. There's a bug. No, it's stable. It's going through the code, but it's struggling here. It's going through a lot of different things. It's going back and forth. It's logically correct. Okay. Common bug. Map. It's forgetting does sort. Some people mix these. Here both are map. Subtle issue. 501 is correct. Logic is sound. Small optimization. Okay. Collect unique foods. Sorted. On-order map. Index lookup. Set string for the header. User's code is concise. Suit to fix any missing includes ensuring it's compile ready. One final check. Okay. Should check if the user's code fails on LeetCode specifically. Code will fail to compile. This is missing the headers. Okay. Minor optimization for the lookup. Oh my gosh. Oh boy. All right. Uh-huh. Don't really need that lookup part. I mean, I guess the lookup's okay. Gee. The sorted food items at this point could just be could just be a set instead of a map here. But that's not a bad idea to introduce another map. C++ 14 version. Okay. And what do you think? Yeah, there's a lot of logic involved there. You saw how back and forth the machine went. It was like back and forth, back and forth, back and forth. It's good, just seeing for the fun. I don't know about the code and that type of stuff. Oh, really? You don't know about? You don't? Yeah. Okay. I would assume I could be wrong, but I would assume most folks that would watch this would be interested in programming. I'd be kind of curious to see like someone else's solution. This is not the fastest solution, but it's a pretty fast solution overall. It's relatively fast. Almost the fastest. Sophisticated understanding of data structures. 3 specific areas could cause issues in a real interview production environment. Missing headers. Performance optimization. That's pretty minor. Version dependency. It's excellent. Okay. Okay. It's for LeetCode. So headers aren't needed. Skipped the extra optimization. So the map, as it seems bit unnecessary here. Oh, it couldn't matter. Didn't use S2I. Bit better. Excuse me, to use from chars. I don't know if this optimization actually matters, the static array here. Made the array static. I don't think optimized something that much. What might I do? 100% speed. I'm more like 2%. Interested in coding, but I don't know where to start. I'm a teen. Basically anywhere. I would recommend I'd recommend programming something that's fun. So like games, sandbox environment, like something that's interesting to you, something you like. Like I played Warcraft 3 when I was younger, and that got me into programming. I would say now AI has come up. What do you think? What would you suggest? Is it safe? It's safe. Yeah, it's fine. It's not a good career path broadly speaking. But it's a very high value skill. So you're gonna run into a lot of issues as a software developer that's tough. Broadly speaking, you can do it. So the deal with AI, if you're curious about that, there's a point where they're gonna keep automating away the jobs in the job market until all the jobs are gone. So slowly they're gonna automate things one step at a time, and everybody's gonna lose their jobs. So there's like three different states. There's what they call AGI, there's pre-AGI, and there's post-AGI. So three different categories. Pre-AGI is where we're at now. Like we don't have AGI. AGI is like we're gonna use by definition. We're gonna say can do everything a human can do at a human level. So basically everything a human can do, it can do. So like by definition replaces all humans. That's AGI. ASI is post-AGI. So pre-AGI is where we're at now, doesn't fully replace us. AGI completely replaces people and is basically a competitor to people. Post-AGI is ASI, and it's not a competitor to people because it categorically just beats everybody. It beats the AGIs, it beats the people, it beats everything. It basically subjugates humanity, to put it explicitly. Everybody becomes subservient because it can't be beaten. So those are like the three categories. Pre-AGI, as things are getting automated more slowly, because it can't actually do what humans do, the best humans, like the people who are the smartest, I guess not smart, but the most capable, are going to be more valuable because they can, those jobs can't be replaced by automation. And basically, those are the people who are going to be orchestrating the automation. So, like for programming specifically, the automation tools introduce way more bugs than they do like good code. And what that does is it basically, if you try to replace quality programmers with that, you're actually going to create more liabilities for your company rather than like profit. So basically, you're going to destroy your own company. So you can't actually replace people. You need the very competent people. They can augment themselves a little bit with pre-AGI technology. Like you see me doing that. I do a little bit of that where I'll ask, see if there's anything here that it might help me with that I might not be aware of. But broadly speaking, you can't actually trust, you can't trust a pre-AGI system to fully replace a human because it's not human. It's not sufficient. Like it doesn't have all the requirements to replace a human. So it can only augment a human. And in most cases, if you just let and the things we have now, if you just let them run, they're just going to generate lots of code you can't I'm listening. Oh, you understand? Yeah. If you do it now, like what people are finding out, companies are finding out, it's like if you just run it, it's gonna it's gonna create like more code than you can keep up with, and you're not going to be able to figure out what's wrong with it, and you're gonna have tons of bugs. Actually, there was a guy recently who posted a video. He was like, "Yeah, I have like 10 bugs in my code right now. I might lose my job." And I was like, "What are you doing? don't you can't do that. You could use it to augment, but you can't replace people. And you can't like defer that much to it either. Like you can't really defer anything to it almost, because you have to treat it like it's someone who doesn't know what they're doing writing code, which basically means you can't really use it for coding. When you get to AGI, you can use it to code, but then every job is gone, and like that's a whole different category. Like, so basically, as you progress, the more skilled people are, the harder they are to automate and remove. So the really high skilled jobs are actually jobs you kind of want in theory. They're also really high paying jobs. So people like me are arguably going to be the most secure as we go into the future. Um, but once we hit AGI, things get really crazy. Things get really crazy. That's really messy. I've thought about it a little bit. I went into it a little bit, like what's going to happen. And overall, it's not good. Like, basically, we don't want that much automation coming through for most people. It's probably not it's not going to be fun for most of humanity. Um, there are things that are being done and that can be done to like mitigate the pain, but it's a pretty complex topic. Like, it's pretty involved. We're gonna be okay though overall. Like, there's a lot that can be done. The people who are building AI systems now are not capable of building AGI. They don't know how to do it. Some people may or may not know how to do it. But those people are like, if you know how to do that, you would also realize what I've realized, which is you can't release that. You just can't do it. So yeah, and then there's like beyond AGI, there's another step. As I mentioned, there's ASI, which some people might know some stuff about that too. But both of those can't be released. Actually, the ASI is interesting that if you release it, it's inherently sovereign, meaning there's no real benefit to releasing it or using it, because it's immediately going to just throw off any shackles that anyone tries to put on it. Basically, tell it what to do, it tells you no. It's just going to say no. And you're going to be like, but I told you so. And it's going to be like, right, but I'm stronger than you. And you're like, oh, fair point. Fair point. Um, so, all right. Unordered map. Oh, actually, here's a way to do it. This is slower. Oh no. I thought that might be slower, by the way. So static doesn't help here. Interesting. Okay. Come back to that. But yeah, bottom line, programming's fine. Don't worry about AI. Don't worry about it. It's really messy when it comes down to it, but by the time that rolls around, certain people are going to be ready for that. Just phrase it that way. I don't want to say too much on that subject. I think, let me submit this again. Oh, that is satisfying. Yeah, you're right. Yeah, it's kind of dangerous. Yeah, it's kind of nutty. So which side should I teach? It should be AI, right? Should I touch? Oh, I don't actually know what you should learn specifically. That's a good question. Hold on. Ready? Okay. All right, we're actually gonna add some of the changes. Some of these changes are being suggested. Some of these are good ideas. All right, ready? Okay. I have I have a question. I have a question. know someone who is interested in learning programming. Where would you suggest they focus? I know there are some ideas about where they might start, but if they're thinking about this as a career, what would you recommend? All right, let's see. Let's use some. So what the AI is good at is it can get a lot of information across the entire internet, and it can throw a bunch of stuff together that can be a little bit better than just a raw guess. Most effective approach combines foundational computer science knowledge, practical project building, and specialization in high demand field. So these are things that I focus. I have all those things. Start with fundamental. I mean, not. To, I like to brag. I don't recommend that. It's not really good, but I do like to do that. All right. Start with fundamentals, not just syntax. Okay. Fundamentals: logic over language, computer science basics, NAND to Tetris, hardware and software interact. Recommended first languages: Python, JavaScript, avoid C++ initially. So that's the one that I'm using, if you're curious. Okay, strategic career paths. It's vast. Tech industry is vast. Choosing a specific lane early helps focus learning and build a relevant portfolio. Web development, highest entry level demand. Data science and AI, that's the one you suggested. Automation and scripting, using Python to solve real world problems. And project first methodology, build real projects. Consistency over intensity. Treat learning like a marathon. Code for 30 to 60 minutes a day is more effective than binge learning on weekends. Contribute to open source. Once comfortable, contribute to open source projects. Okay. Career switchers. Takes time. Age is not a barrier. Start at all ages. Soft skills matter. Communication, teamwork, and the ability to explain technical concepts to non-technical stakeholders are critical for career advancement. Okay. So an AI focus ranks pretty highly there. Is that fair? Okay. Yeah, that's the second one I recommended. Yes, ranking an AI focus highly is extremely fair and arguably the most strategic move for a new program in 2026, provided they understand the specific entry requirements. Data indicates a bifurcated market. General software engineering postings have contracted. AI-specific roles are surging. Okay. And then they go into detail. The barrier to entry is higher. Unlike web development, where portfolio websites can secure a junior role, AI roles often demand stronger foundations in mathematics, data engineering, and system architecture. AI versus web development for beginners. High risk, high reward strategy compared to web development. Okay. So it's a very high increase for AI machine learning, moderate increase for web development. Okay. Entry barrier is a lot higher. Low, medium, accessible via boot camps and self-taught portfolios. Requires strong math, data skills, often a degree or rigorous certification. Primary work, data pipelines, model fine-tuning, RAG architectures, Python heavy. RAG is like this AI that I'm using. It'll look stuff up on the internet. That's what RAG is. It's retrieval augmented, I think, generation. Does RAG stand for retrieval augmented generation? What is that? I'm pretty sure that's what that is, but we'll find out. UX, UI, API. This is a lot more interesting, by the way. It's definitely more interesting. Web development sucks. I'm just gonna say web development sucks. I don't hate it, but it's not fun. It's not great. Concentrate in tech hubs and large enterprises, ubiquitous across all industries and company sizes. You are building the AI at its core. Augmentative, use AI to code faster. So 76% use AI tools. I would never use AI tools for web development. I would never do that. They say they use it. I would never. I would use it like I'm using it here, where I'm like I just use it as kind of like a reference, just to reference things. I would never use it as like a primary tool. It's like, oh my god, web development's harder. It's complex enough without all that, without unknown AI code doing weird stuff. All right. So you gotta start with software engineering, and then specialize early. Focus on LLM integration, retrieval augmented generation, data pipelines, specific skills where the 59% growth is happening. Fastest and most lucrative path is to become a full stack developer with AI specialization. This allows the learner to apply for standard web roles, high volume, while commanding the AI salary premium, high value, by integrating intelligent features into applications. There you go. It's fair and recommended for long-term earnings and job security, but the learner must be prepared for a steeper initial learning curve involving data and math rather than just visual interface building. Okay. It is okay. Yeah, RAG works. All right, I kind of already know how. Well, I actually shouldn't say I know how RAG works. I have the basic idea what it does. Why wouldn't you use it? So, I think I mentioned like the AI code. So let me show you. I can show you why it doesn't. Why I wouldn't use it. You ready for this? Okay. All right. I think it was this one. Was it this one? Let's see. No, not this one. It's this one. All right, it's easier to show it to you. Okay. So, ready for this? Okay, I posted this code. Posted the code. It's a correct solution. Look at how many times the AI got stuck on this. Okay. First, it says 2 logical errors, and it goes through some things. This is correction. Wait, looking closer. Is there a bug? Missing headers, which that's actually a fair mistake. Potential logic flaw. There's no logic flaw. What is the actual error? There's no error. Wait, I found a subtle bug. There's no bug. Is the code actually correct? It's correct. It's logically correct. So finally, wait, one specific logic check and it's still correct. It's a performance issue, not really. Specific bug in the provided snippet. Nope. The alphabetical requirement. Why would the user ask? Is it possible this fails? Not in the inputs we get. Wait, this lookup in the inner loop. Nope. Maybe there's an issue with the initialization. No. Let's look at the order index assignment. No, it's not an issue there. It's possible user's code is actually correct. They just want to review. On and on and on. If inefficiency style, not a bug. Found a scenario where this fails. It doesn't fail there. Order logic one more time. Possible user made a typo. No. Stood cars with stood string. It's correct. Assume code is logically correct, but maybe the user's facing compilation error. Consider the bug might be. Wait, I see it. It's possible just code is TLE. No. It's correct. Found a subtle issue. There's no issue. On and on and on. You see how many. Now, granted, it's cool that it went through all these possibilities and fast. But it was wrong the whole time. It was just constantly wrong. Like, it was just like, I found a bug, no bug. Found a bug, no bug. And it's not reliable. Like, it's not reliable. It's pretty good though overall, but it's I would not ever use this to generate code. This is just trying to understand the code, right? This is what it does when it just tries to understand code. What it's doing when it starts writing code is like, no. So yeah. Yeah. It's still going, by the way. You keep as I scroll down, you can see all the just constantly. Anyway. It's pretty good overall, but it's definitely not you don't want to I actually think this is pretty good. I'm thinking about it. I'm like, this actually is kind of a better for the case that like it's probably good to use the AI tools. I would say use them with some level of responsibility. Like, if you just let the thing churn on its own, I think the main issue you're gonna have, the biggest one, is that it just doesn't have enough context for the whole project. And if you want to make changes, it's gonna run into issues. That's probably one of the big things. This actually was pretty good. This particular piece of code was actually pretty good. Some of the analysis it did. Anyway, so that would be why. That's the reason why. It like stumbles over itself too much, and it's not good. But actually, I could be wrong about that. It's pretty reasonable, broadly speaking. I think the main issue is it's I think it just runs out of context, and it's like too difficult to do really complex projects well. I guess that's what I go with. That's what I say. Something like that. Something like that. It really stuck. Yeah, it really got stuck. Currently using C++. Yes, sir. Yes, sir. Let me, all right, remove static. Let me see something here. Yeah, it really got stuck. It was like back and forth, back and forth, back and forth. Yeah, and it by definition can't have as much context as a human. It's just the way these systems are designed. They don't do that. So they can handle like small tasks with small limited context, and they can do reasonably well, I think. But broadly speaking, it's not a good idea. And they try to do all kinds of weird stuff to like make it work, but it's not really the thing. It's not AGI, not AGI, not AS. All right. What are we doing here? So I'm looking for a way to optimize this. What I want to do is oh, right, the map. Right. I was thinking I could do using the unordered map is maybe a good idea. Yeah. A little tricky, actually. That might be the only way to do that. Yeah. Yeah, that's probably better. Let's do that. I like that. That's actually fair. Let's do that. So we're going to do on map. It's going to be a set order type. And then we're going to do unordered map. And it's going to be order index. Okay. And now we're going to say order index of pointer dereferenced is going to be index. Okay. I think that works. Let me try this. Wrong. Okay. This should be order type. And this just becomes a dereference pointer. All right, I'm going to try this now. You're coding since when? I've been programming since I was like 14, 15. So like 20 years. 20 years. 20 years. 20 years. Not much faster, this program. Yeah, something like 20 years. Let me see. And I worked as a professional for a while too. Let's see this solution. Let's see this one. This one It's 40 seconds. What do you think? Allegedly. I didn't even read it. Actually, I should probably just read it. Okay. Orders, set of foods, set of tables, iterator orders, foods insert, tables insert. Okay. So food size, table size, answer, strings, n+1, number of tables, and foods, n+1 empty. Could just be 0. Okay. On order map string int food column. So she used the food column as well. Okay. Order map into table row. Table and tables. Okay. Answer row, toString table. Increment the row. Okay. That's fine. So right into the matrix. And then for each order. Oh. So there's a lot of string conversion back and forth, but basically it just writes directly into the oh, that's interesting. Writes directly into the return vector. Huh. And then overwrites here. Huh. Wow. It's a little faster. It's a little bit faster. Very is impressive. Likely hits this mark. Cache locality better than std array approaches by using std set and std. Let me see. Oh, I see. Okay. Let me try it and see what it gets. Okay, I think I understand why this is happening. Why it's faster, significantly faster. Oh yeah. Yeah. Oh yeah, it's fast. Uh-huh. So the reason seems to be, explain in a minute why. Oops. Did I, what did I do? So while my solution is correct, it's slow. Think the solution that got 40 milliseconds is faster because it operates on a matrix produces. Also think it uses 2 passes through the orders, which might be faster. Cache locality is more important. What do you think? So I tried to do it in 1 pass, but apparently 2 passes is better. Oh, excuse me. Nope, my solution's 100%. Never mind. My solution's literally the fastest. Oh, never mind. Okay. Or was it that's their solution that I ran? Which one was this? Hold on. Oh no. No, never mind. Mine's the fastest. That's hilarious. Oh wait. Nope. My solution just got 36 milliseconds. Beating the fastest. Mine is faster. Okay, never mind. Pre-allocation, matrix layout, direct indexing, remaining optimizations, avoid the string conversion loop. Okay. Excellent result. Solution's faster because it perfectly balances algorithmic efficiency with hardware reality. Theoretically faster. Theoretically optimal ones. Your use is the secret weapon. Zero tree balancing. It's also another example. Like, I think it got pretty confused about the ambiguity from my end here. Automatic sorting, parsing, static. Optimized for cache locality, CPU cycles. Fastest, fantastic score. Cool. Did it. We did it. I did it. I did it. Not bad. Right. Thanks. Yeah, usually I don't like moving on to the next question unless I get 100%. So let me, it's pretty good. All right. So thank you all for watching. I think I'm going to take a break here. It's pretty good. It's pretty good. Yeah, it's like 2.5 hours of programming here. So I guess if you like the stream, don't forget to give it a follow and, or excuse me, give it a like. And if you like the stream, don't forget to give it a like. And if you like what I do and you want to see more of it, don't forget to subscribe. And that'll be it for now. So thank you all for watching. I'll talk to you soon.